We have some guided notes here for 2.5, which we are going to talk about factoring binomials. And mainly we're focusing on patterns, some different patterns that you'll need to recognize and memorize. First one we talked about here is difference of squares. So you're going to need to have this formula here copied down. And this is one that we've already talked in class about as well. So when we have a difference of squares here, so for example, a squared and b squared are both perfect squares, and we have a difference, which is subtract. It's always going to factor out to be a, which is the square root of a squared, plus b, the square root of b squared, times a minus b. Always. So b, sum of squares formula, no formula. Okay, a sum of squares, for example, a squared plus b squared is not factorable. Okay, this cannot be factored. So let's practice a couple of these. So it says factor each binomial fully. So x squared minus 25, this is definitely a difference of two squares, right? I could rewrite this like x squared minus 5 squared, right, instead of 25. So we can say that this factors out. My a term is x, my b term is 5. So this would be x plus 5 times x minus 5, following that formula. This is a difference of two perfect squares, right? So I could rewrite this like this, 8x squared squared, right? That's the same thing as 64x to the fourth power, plus 3 squared. So my a term is 8x squared, and my b term is 3. So this would factor out to be 8x squared plus 3, and 8x squared minus 3. Next, we definitely have a GCF here between the two terms. They both share a factor of x, and they definitely have a 2, which is a common factor because they're both even. It looks like probably larger here, so we'll have to test them out. Let's see if 242 is divisible by 32. It is not, so we'll have to try a smaller factor like 16. 242 divided by 16. That doesn't work either, so we're going to have to go even lower than that, possibly 8. 8 is a factor of 32, so 242 divided by 8. That's not a factor either, so maybe let's keep going. Maybe, what's the next factor of 32? It's not 6. Maybe it's 4. 242 divided by 4. That doesn't work either, so it's only 2, surprisingly. So that means that 2 and x is the GCF because they both share a factor of x. So when I divide that, 32x squared divided by 2x is going to give me 16x. 242 x divided by 2x is going to give me 121. And that is it. That's the way I'm pretty sure this worksheet is supposed to mean if it's cubed. Well, if it is cubed, that makes that squared. This is a perfect square, and this is a perfect square. However, this is a sum, so it's not factorable. Therefore, that is our final simplified answer. Next one here. So just looking at 18x squared minus 8. So we definitely have a GCF because we have even numbers. Looks like it's going to be 2, so I'm going to factor out a 2, not x, because the second term doesn't share it, so that's going to give me 9x squared minus 4. And yes, these can both be factored because that is a perfect square and that is a perfect square, right? And we have a difference, so this will factor out to be 2 times my a term would be 3x, right? That's the square root of 9x squared, plus 2 times 3x minus 2. Okay, and don't forget, you still have your 2 GCF that you factored out in the very beginning. That's going to stay to your final answer. So that's factoring, basically focusing on sum of squares, which is not factorable. So you notice how we got to that point. We couldn't factor, and difference of two squares, special product pattern. Let's look at the next product pattern that we need to know is sums and differences of cubes. So you see one formula here because they really only have one formula. but the signs change. So for example, if I have a perfect cube plus another perfect cube, so this is the sum of two cubes, this will always factor to be a plus b times a squared minus ab plus b squared. Now, what if we have a difference of cubes? Well, a difference of cubes meaning we would have, let's say this is a minus sign there, right? That would mean it's a difference. Well, the first sign is always the same. Well, that means now it's a minus b, and then this is always opposite. So instead of negative, that would become positive, and this is always plus. Okay, so same, opposite, always positive. Okay, but it's factoring out the same exact way. So it's either a sum or a difference, and you are essentially just changing the signs is the only difference between the two. Let's try some of these. Let's look at this one for an example. So we have 125x cubed minus 8. So we definitely have a perfect cube here. So the cube root of that would be 5x. Right? 5x raised to the power of 3 would give me 125x cubed. 8 is a perfect cube. That is 2 cubed. So we have a difference of 2 cubes. So this is going to factor to be a minus b difference, right, times a squared. Remember, when it's a difference, right, if it's the next sign here, this sign's always the same, this one's always opposite, and that's always positive. So same, opposite, and then always positive on the end. So we have a times b, and b squared. A times b, and b squared. So my a term is essentially 5x, and my b term is 2. So this will factor out to be 5x minus 2 times, okay, well, I got to take my a term here, 5x, and we're going to square it, right? Plus, what is a? 5x times b, which is negative 2. I'm sorry, not negative 2, positive 2, and then plus b squared, which is going to be, my b term is 2, so 2 squared. So we just have to clean up this part a little bit. So we have 5x minus 2 here, but 5x squared, that actually is 25x squared, 5x times 5x, and then 5x times 2 in the middle will give us the plus 10x, and then the 2 squared gives me 4. So that is going to be our final factored answer. Let's look at this one here. So we definitely have a perfect cube here, right? So the cube root of 27y cubed is going to be 3y. And the cube root of z cubed is just z. So plus z cubed. So we definitely have a sum of two perfect cubes, which will factor to b. So I got my a, my b. We got what? A squared. We got ab in the middle and b squared. So the key is remembering the signs. Okay, so if we go back up to our notes, we notice that what? If it's sum, right? If it's sum of cubes, we'll have what? The same sign here, different here, opposite, and always positive. So since it's the sum, it's the same, it's opposite, and it's always positive. So let's just plug in and we'll see what we get here. Our a term is 3y, b term is z, so 3y plus z times, okay, a squared, so that means 3y squared, which is 9y squared. So that gives us 9y squared. Okay, a times b, so that's 3y times z, which is just 3yz. So minus 3yz, and then b squared is just z squared, right? So plus z squared, and that is factored. Let's try another one here. So notice how on this one we have a GCF. We should be looking for a GCF every time, no matter what. So they both have a factor of p squared. So I'm going to factor out a p squared, which gives us p cubed minus 64 when we do that. Well, now we're going to have a difference of two cubes, right? P cubed is a perfect cube, and 64 is a perfect cube. This would be what? p cubed minus 4 cubed. There's your a and your b term, right? So we have to continue to factor that. So this is a difference. So we're going to have p squared times p minus 4. Remember, always the same. So it's a difference. So p minus 4 times a squared. So remember, this is just a minus b. And this part here is going to be a squared plus ab, because different sign, and then this is always positive. So my a squared means p squared, a times b means p times 4, which is 4p, and b squared is just 4 squared, which is 16. So this is your final factored answer, just following the pattern. Next one, we definitely have a GCF here. We have coefficients of 5 and 40. So we have a common factor of 5, and then they both share a factor of n that we can factor out. So 5n is our GCF. If I divide that, that means I'm going to have m squared. Excuse me, not squared, it's still cubed. And we have plus 8 remaining, which gives us a sum of 2 cubes. So let's write it out. So we're going to have 5n. Pick a different mark here. So we have 5n times, okay, let me put this in a different color here. So above here we're going to have a plus b, same sign, right? And then let's make our parentheses for the rest of it. So here and here. And in this one we're going to have a squared, opposite sign, so positive, so minus ab, and then always positive, b squared. Okay, so let's fill it out. So our a term is essentially, so we're factoring m cubed plus a, which means it's what? M cubed plus 2 cubed. So our a and our b is m and 2. Okay, so a is m, b is 2, so m plus 2, m squared minus a times b is just m times 2, which is 2m, and then b squared is 2 squared, which is 4. And this is your final factored answer. Let's see if you guys can try these last 4 on your own. At the 1250 mark, you will see the answers from these, and you'll be done with the notes. So pause the video, please. Since we're past 1250, it will be at the 13-minute mark. You will see the answers. Okay, these are the answers you should be getting for E, F, G, and H. If you need help, or you want me to go over any of those, just make sure you let me know. And I'd be happy to do that. Make sure that you are factoring out the GCF. F, G, and H all had a GCF that you had to factor out prior to using the pattern.